In this video, we'll be focusing on calculus. Calculus has two parts. Calculus has two parts. Calculus has two parts. It has the integral, the differential calculus. Differential calculus and the integral calculus. Integral calculus. But in this video, our focus will be on the differential calculus, where we'll be looking at different concepts under it. So let's get in. So differential calculus. Differential calculus. Differential calculus. Differential calculus. So the first thing you have to understand under differential calculus is the idea of variable and constant. Idea of variable and constant. Because if you understand this, it should really help you when we move on, and also when you get to other aspect of calculus, variable and constant. Variable and constant. So let me start by writing this. If we have, let's say we're given this, we're given z to be equal to alpha raised to power 4, beta raised to power 5, y raised to power 6, x raised to power 7, and let's say d, let me use d, let's say k raised to power 10. Now, the first thing we have to understand here is the idea of variable and constant. Now, let me just quickly say this, though we haven't really started it. Let me just quickly say this. In calculus, if you are given this, if you have y, let me just see this quickly. If you have y is equal to x raised to power 4, if you are to find dy dx, you have to bring down this 4 will come down, then you write everything back and subtract 1 from 4. That means you have 4x raised to power 3. Let me write another thing again. Let's say we have y to be equal to x raised to power minus 6. You have dy dx to be equal to minus 6 will come down, minus 6, then you have x raised to power minus 6 minus 1. That means we are having minus 6 x raised to power minus 7. So don't forget that. Though I will still explain all this standard, but I want you to have this in mind so that I'll be able to use this idea. Let me clean that. So that I'll be able to use that idea to explain the idea of variable and constant. Because if you get the idea of variable and constant, it really help you a lot. It really help you a lot. Now, many times in calculus, we had dy dx, we had different the clinical. Now, the idea of differential calculus is that we are focusing on the rate at which one quantity is changing with respect to other. So if you have dy dx, it means that the rate at which y is changing with respect to x. For instance, if you look at circle, you have circle. For circle has radius. Look at this circle. If I draw another circle, look at this circle as well. Let's say I draw another circle. look at this circle as well, just to give you the idea of differentiation, which is also known as differential calculus. Now, if you look at this circle, the area of this circle is bigger than the area of the circle, and the area of the circle is also bigger than the area of this circle. Now, what really is the difference between all these circles is their radius. That means the rate at which area is changing depends on the rate at which radius is changing. So if you have a small radius, that means you are expecting a small area. So if I want to write that, I will write that is dA over dr. That is the rate at which area is changing with respect to radius. So that's the idea of differentiation. The rate at which one quantity is changing with respect to another quantity. So now let us go back to the idea of the variable and constant, because if you get this idea of variable and constant, it really helps you a lot. Now, the moment I write the z, don't forget z is outside, the z dx. The moment I write the z dx, you know what we have here? We have z, we have alpha, we have beta, we have y, we have x, we have k. The moment I write the z dx, what does that mean? It really means that x, z, and x are the variable I'm having here. They are the variables I'm having here. Anything else are constant. So this, and this, they are constant. Did you get that? Because what did I ask you to find? I asked you to find the z dx. That means your focus will be on z and x, not any other. Any other thing will be on one side. So your focus will be on z and x. Please and please try to get this thing. It really helps you a lot. So z and x are the only variable I'm having here. Let's say what I ask you to find is, let me write this thing. Let me just clean it. Let me just clean it. Let's say what I ask you to find is the z decay. The z decay. What can we derive from it? It means that z and k are variable. They are variables. The rest, they are what? They are constant. All these are constant. Can you see that? This will really help you a lot, because we have many variables, we have many quantities here. We have z, alpha, they are all quantities. But the ones we are focusing on now is z and k. Now, you should be able to tell me in the comment section, if I ask you to find the z, the beta, what are the constant and what are the variable? And why do we always have z here? Because z is the subject of the formula. Z is the subject of the formula. And this is kind of the differentiation called explicit. We are still going to look at implicit as well, but this is explicit. This is explicit. So please try to understand the idea of variable and constant. Now, let me do different examples. So let me start from the z dx. The z dx. Now, once I'm asking you to find the z dx, that means every other thing are constant. I will be applying the the concept of differentiation only on x. And what did I tell you earlier? I said that this 7 will come down. 7 will come down. You have x 7 minus 1. Look at this. That means we are having alpha raised to power 4, beta raised to power 5, I raised to power 6. So we have, okay, let me put 7 here, x raised to power 6. You can see that every other thing, they are constant. So the only variable here is z and x. Now let me do the z, the beta now. The z, the beta. If I do the z, the beta, what is going to happen? That means alpha is a constant. I'm not touching it. Alpha is a constant. I'm not touching it. Now, beta is the variable. That means 5 is going to come down. Alright, beta 5 minus 1, because beta is the variable I'm working with now. Y, nothing will happen to y, is a constant. X, nothing will happen to x, is a constant. K, nothing will happen to k. K is a constant. So finally, I have 5 beta raised to power 4, y raised to power 6, x raised to power 7, and k raised to power 10. Now, let me do this last one. The z, the k. The z, the k. Let me do this last one. The z, the k. The z, the k. Now, every other thing, apart from k, they are all what? They are all constants. So that means alpha raised to power 4 is a constant. Alpha raised to power 4 is a constant. Beta raised to power 5 is a constant. Y raised to power 6 is a constant. X raised to power, what's that? 7 is a constant. That means I'm focusing only on k raised to power 10, so the 10 will come down. I have k 10 minus 1. That means I'm having 10 alpha raised to power 4, beta raised to power 5, y raised to power 6, s raised to power 7, and k raised to power 9. That is the answer. So the k, the z is this. Hope you are following. Subscribe to the channel so that you can have access to different videos that treat the concept very well. Now that you've understood the idea of variable and constant, now let's now move to differentiation proper. Now, I'll be looking at first principle in my other videos, but in this video now, in the first principle, though I'm not using the first principle here, I'll just explain the concept. In the first principle, you'll be using the idea of limit of function. Let's say you have y to be equal to f of x. You'll be having your dy dx to be limit as the x approaches 0, f of x plus dx minus f of x over dx. So you're having this. So this is referred to as first principle. Using first principle for your differentiation. But I'm not going to use that one now. In this video now, I'll be focusing on what I call differential standards. Differential standard. So now we will now be looking at those standards one after the other. Differential standards, very simple. just try to follow it and subscribe to the channel as well. So we have differential standards. So what is the first standard that we are looking at? What is the first standard we are looking at? So the first standard is called power rule. And what is power rule? It states that whenever you're having this kind of question, don't forget both x and y, they are variable. N is a constant. You are having this where n is a constant. Don't forget that. This is very important. Where n is a constant, you have dy dx to be n will come down. You have n, you have x, you have n minus 1. That is the standard. So that is the first standard. Let me write the first standard there. The first standard. So that is first standard. That is the first standard. You have y is equal to x raised to power n, where n is a constant. Because you can have a situation whereby n might not be a constant. Let's say you have x raised to power x. You can't use this method for x raised to power x. You cannot use this method for x raised to power x. You can't use this method. You can also have x raised to power sine x. You can't use this method as well. But for y is equal to x raised to power n, where n is a constant. So a constant, your constant can be anything, apart as long as it is not the variable we are working with. Don't forget, the variables we are working with in this question is y and x. I've already explained that. So let's check the different examples. Let's check different examples. And in this standard, mostly what you'll be using most is the idea of indices. So let's check the first example. Example number one. Let's see, you have to find, find one. You have to find dy dx. So find dy dx if y is equal to 8x raised to power 7. Find dy dx if y is equal to 8x raised to power 7. So how are we going to do that? So we say y is equal to 8x raised to power 7, and we have dy dx. Don't forget, as we said above, only y and x are the variable. Anything different from them are constant. That means I will put 8 here. I will focus on x raised to power 7. Now, according to the standard, this is my n. This is my x. So, according to the standard, n is coming down. That means 7 is coming down. 7 is coming down. Then I'm going to write 7 is coming down. So if 7 comes down, I'll write x back. Then I write 7 minus 1. dy root n minus 1. So that means finally I have 56 x raised to power 6. Look at that. That's very simple. So number 2, let's check the second example. Let's check the second example. So you can also write it like this. Find the derivatives of let me say cube root of x raised to power 2 with respect to x with respect to x. So respect to x, respect to x. So finding derivative as well is same thing as asking you to differentiate. It's still the same thing. So now in this question now we are asked to find the derivative of this with respect to x. So you can represent this with anything. You can represent it with anything. Let me represent it with z. So the solution is z is equal to this. So what is my goal? I'm asked to find dz dx. dz dx. Now, in order to be able to do that, don't forget our standard. What is standard? Our standard is x raised to power n. N will come down. We have n minus 1. We have n minus 1, n raised to power n x raised to power. Now, this guy doesn't look like our standard. Our standard is x raised to power n. This thing doesn't look like our standard. So what are we going to do? We use the idea of indices. Don't forget in indices, root x. In indices, root x is x raised to power 1 over 2, and cube root of s is x raised to power 1 over 3. Fifth root of x is x raised to power 1 over 5. So look at that. So we can use the same concept here. That means we are just going to write this as, in order for it to look like our standard, write x raised to power 2, which is what we have here, 8 raised to power 1 over 3. And what is that? That is x raised to power 3 over 2. Now, since we have x raised to power 3 over 2, now we have what looks like our standard. So from the standard now, this is n. This is n. So we can see dz dx now is now 3 over 2. 3 over 2 is our n. It's coming down. 3 over 2 x raised to power 3 over 2 minus 1. 3 over 2 minus 1. And what's 3 over 2 minus 1? You can use this code. 3 over 2 minus 1 can be written as 2 over 2. So you have this. 1 is same as 2 over 2. So we have 1 over 2. Good. That's very simple. So we have 3 over 2 x raised to power 1 over 2. Look at that. And which is same thing as 3 over 2 cube root of square root of x. That is number 2. Number 3. Let's say we have y is equal to let's say we have 4 over 5th root of x. Let's say we have this, and we are asked to find dy dx. We are asked to find dy dx. So how are we going to undo this? How are we going to undo this? How are we going to undo this? Now, y is given as 4 over 5th root of x. 4 over 5th root of x. We write this as 4 times 1 over 5th root of x. Don't forget, this doesn't look like our standard. What is the standard? The standard is x raised to power n, and it doesn't have 1 over anything. That means we have to apply indices as well. And how are we going to apply indices? We are going to have 4 times 1 over x raised to power 1 over 5. So from indices, we have 4 x raised to power minus 1 over 5. Because in indices, x raised to power minus a is 1 over x raised to power a under indices. So now, what we have here now, so that means y is this, and from here now, this is our n. Our n is minus 1 over 5. So to find dy dx, is now, don't forget this 4 is a constant. You put it at one side. Now we bring down minus 1 over 5. We have x raised to power, so we are going to subtract n minus 1 from n. So minus this minus 1. So what is that? We are having minus 4 over 5 x raised to power minus, don't forget, you can quickly do this, minus 1. Once you have 5, you can write this as 1 as 5 over 5. So you have minus 1 over 5 minus 5 over 5. That's minus 6 over 5. So that's minus 6 over 5. So we have minus 6 over 5. So finally we have minus 4 over 5. So this can come down. This can come down. So you will remove the minus. Once it comes down, you remove the minus. So we have minus 4 over 5. And we can write this as 5th root of x raised to power 6 from the idea of indices. So that's the final answer. Now, what is that? Number 4. So let's say we are given y is equal to, let's say, 5, ordinary 5. And we have to find dy dx. So what is that? 5, it doesn't have any x. So how are we going to apply the standard on it? What are we going to do in order to apply the standard on it? We have y is equal to 5, and from the idea of indices as well, we have, if you have a raised to power 0, you will say is 1. If you have b raised to power 0, you will say is 1. That means if you have x raised to power 0, it's the same thing as 1. And 5 times 1 is 5. That means instead of writing 5, I can write x raised to power 0. And that means I've introduced x to it. So this is my n. And to get dy dx, we have 5. This is 0. It will come down. We have 0 times x raised to power 0 minus 1. Now, 5 times 0, anything times 0, we have 5 times 0 times x raised to power 0 minus 1, so we have 0. That means if you are differentiating a constant, you are going to have 0. Let's say we have 5 is equal to 8. It doesn't have anything. So your dy dx is 0. They don't waste time on it. So number 5, let me combine. So let me conclude the first one by combining these together. So let's see, y is equal to 8x raised to power minus 4 plus 7x raised to power minus 2 plus 6x raised to power 4 plus 7. Let's say I have this. Let's say I have this. So how are we going to undo this? Since what we have is already in terms of the constant, or the standard, this already, this is our n, this is our n, this is our n. So we just say dy dx. Dy dx is given by us. 8 is a constant, so I just write minus 4x minus 4 minus 1 plus 7 minus 2x minus 2 minus 1 plus 6 plus 6. I have 4x power 4 minus 1. And lastly, I have the differentiation of constant is 0. 7 is standing alone, doesn't have any variable attached to it, so that's 0. So finally, I'm having minus 32x raised power minus 5 plus times minus is minus 14x raised power minus 3 plus 24x raised to power 3. So that's it. Now, from the idea of this constant now, from the idea of this first standard, I can explain another concept. Let me explain another concept. Let me explain another concept from the idea of the first standard. Don't forget, this is the first standard. This is the first standard. And we said the ds is this. The ds is this. Now, let me explain something now. Now, when trying to carry out this, now I'm moving to a little bit advanced now. Now, when trying to carry out this step, we meet something here. Something is missing here. There is something we are missing here. Something is missing. And what is that thing? Now, listen attentively. I want to listen attentively. Now, when we have y is equal to x raised power n, you can see now I'm using the red marker. You can see now. Now, when you were trying to differentiate it, when you're trying to find your dy dx, you brought down this n, right? N. Now, we also differentiated this x as well. And if you differentiate ordinary x raised power 1, if you differentiate ordinary x, what are you going to have? You have 1 x 1 minus 1, and that is what? X raised power is 0, 1, which is 1, we have 1. That means we also differentiated this x as well. We also differentiated what? This x as well. And if you differentiate the x, you have 1. Then we now write everything back. We subtract 1 from x. This is the standard way of writing it. Because we also differentiated this x as well. Because what we are going to do now, we need this concept so that you will not be wasting time on it. Instead of you to be telling you to represent them with some, no. So let me give you an example. Let me give you an example. So please subscribe to the channel so that you can enjoy more of this kind of video. Let's say you were given this. Let's say you were given this example. Examples number 1. Let's say you were given this y equal to, let's say you have x raised to power 4 plus x raised to power 3 raised to power 100. And you're asked to find dy dx. How are you going to do it? And without wasting time. How are you going to do it without wasting time? So you are given y is equal to x raised to power 4 plus x raised to power 3, everything raised to power 100. Everything raised to power 100. So how are you going to do this without wasting time? This is the idea. This is the idea you are going to use. What are you going to do? You say dy dx. The first step. Bring down this 100. 100. Followed by differentiate what is inside this thing according to what we've done earlier. So for the first one now, we have 4x raised to power 3 plus differentiate this one as well. 3x raised to power 2. Now, the next thing for you now is to write everything given back. What are we given? We have x raised to power 4 plus x raised to power 3, 100. You will now subtract 1 from that 100. That is the concept. That is the concept. And that was what I was trying to explain here as well. You bring down the n, you differentiate x, you have 1. But because of n times 1 is still n, that was why I wrote this one the other time. So we are also differentiating this x as well. We are also differentiating this x as well. Also differentiating this s as well. So what are we having now? Here now we are having, finally we are having 100. We are having 100. We are having 100. 4x raised to power 3 plus 3x square. We have x raised to power 4 plus x raised to power 3 raised to power 99. You can see now, with just 2 steps, we are done. Instead of wasting time on it. Let's check another question as well. So what about if you are given this? You are given 2 open brackets 2x raised to power 10 plus 8 over root x, everything raised to power 7. Everything raised to power 7. And you are asked to find dy dx. You are asked to find dy dx. So how are we going to undo this? What are we going to do to undo this? Let's do it. So we have y to be equal to 2 open brackets 2x raised to power 10 plus 8 over root x 15 raised to power 7. So this is very simple. The first step is let 8 over root x. The x there doesn't follow the standard. So we have to first rewrite it in order for it to follow the standard. So you have to write it as 2. You have 2x raised to power 10 plus 8 x raised to power minus 1 over 2 raised to power 7. So you can see now we have this. So dy dx is what? So the 2 we have outside. The 2 we have outside. Don't touch it. Just leave it. Now, 7 will come down. 7 will come down. We differentiate everything we have here. And if you differentiate everything we have here, according to the standard, you have 20. You have 20 x raised to power 9 plus this is minus, because that's 8 over 2 minus 1 over 4 x raised to power minus 1 over 2 minus 1. Let me just write it like this. Then multiply by, you now rewrite everything that we have here. Don't write these two, this already. You now rewrite everything back. You write everything back and then subtract 1 from the 7. You can see now. This is very, very simple. So finally we have 2 times 7 is 14. So we have 14, 20x raised to power 9 minus 1 over 4 x raised to power, that's minus 3 over 2. So close the brackets. So you have 2x raised to power 10 plus 8x minus 1 over 2 raised to power, this is 6. And I can also write, finally I can write everything as 14, 20x raised to power 9 minus 1 over 4 cube root of s cube. Then 2x raised to power 10 plus 8 root x, not root x, 8 over root x, everything raised to power 6. You can see that. Raised to power 6. Number 3. What if we are given, let's say we are given z is equal to 5 over 2s square minus 8x plus 5. So you are asked to find dy dx. So you can pause this video. You are trying to ask dz dx. So you can pause the video to do it, and let's see what you get. So to be able to do that, that's very simple. So we have dz dx. Oh, let me first rewrite it in order for it to, because it has to come up. So 5 is here. Now let us bring this thing to the denominator. That means we are going to have 2x raised to power 2 minus 8x plus 5 raised to power minus 1 over 3. Don't forget, 1 over cube root of x is same thing as x raised to power minus 1 over 3. So bringing this up above to the numerator, we'll be having this. We'll be having this. Let me clean this. So carrying out the differentiation dz dx, we have 5. We have 5 minus 1 over 3 will come down. We differentiate what is here according to the standards I explained above. So we have 4x minus 8. Then we write everything back, then subtract 1. Minus 1 over 3 minus 1. So finally we have minus 5 over 3. We have 4x minus 8. And 2x raised to power 2 minus 8x plus 5 raised to power. Minus 1 over 3 minus 1. That's minus 4 over 3. Minus 4 over 3. Because minus 1 over 3 minus 3 over 3. That's minus 4 over 3 without wasting time. Without wasting time. So we have minus 5 over 3, 4x minus 8. So this is the same thing as cube root of 2x squared minus 8x plus 3 raised to power 4. Raised to power 4. That's very simple. That's very simple. So in my next video, I'll be looking at other standards as well. I'll be looking at other standards. So practice this. Practice this. So you can do this and send me the solution in the comment section. Or you can send your solution to my WhatsApp number. You can check the channel description. I will put my phone number there. So try as much as possible to practice a lot of questions on it. I'll still do different questions as well. No, so you are to do this. Do it yourself. Do it yourself. So y is equal to cube root of 3x squared minus 8x plus 4 over cube root of x. And number 2, you have to find the y dx. Find the y dx. And this one as well. You have this. You have 1 plus root 1 plus x. You have this, and you have this as well. So you can do it and let me know what you get in the comment section. You can send your solution to my WhatsApp number. Also, we have let's say we have this one you are asked to find the z dx. Let's say we have y is equal to 5 root x square x raised to power 3 plus 6 over this minus 8. So do the theory and send your solution to me. Thank you. Subscribe to the channel, please.